So just as a reminder, octal is a base 8 number system based on the digits, 8 to the 0, 8 to the 1, 8 squared, and then we have some values that go in front. But more importantly, the numbers each digit can take on the values 0 through 7. So when we talk about the numbers, you'll only see the numbers 0 through 7. You won't see 8 or 9 in octal because remember, 0 is one of the digit places or one of the digits itself. So if you go to 7, 7 plus 0, the number 0, 1 through 7, and then 0, that is 8 digits octal. So, the basics from 0 through 7, addition, for sums of 0 through 7, addition works like decimal. And what I mean by that is like 1 plus 1 is 2, 1 plus 3 is 4, 2 plus 4 is 6, 3 plus 4 is 7. So nothing different happens in that capacity. So so if you get a sum that's anything lower than 7, of course, or 7 or less, the math just works out the same. It's just a 7. The instances here is that for sums greater than 7, we must carry a digit over. Now, in one method, and this is not the method that we are going to be utilizing, we call it, difference of 8. So if I have 5 plus 9, that would give me 14, but 14 really isn't 14. What I would do here is I would subtract 8, I would get a 6, and so that just reminds me that 14 in octal would be one of the 8's, 1 6. And so I would have to carry the 1 in addition. Now, the difference of 8 method is tricky. So we will use the table index method. Okay. So, because what happens, we're the good thing here is we're only going to add 2 numbers. Okay. So, since only adding 2 octal numbers the table index is simpler and more efficient. So, if we were going to add 3, 4, or 5 numbers, we might want to go into a little bit more about how to use that difference method to figure and basically converting each of the numbers that we get over. And we're still going to kind of convert, but we're just going to have an index. And an index is something that you can reference, all right? So we're going to reference something. We're going to create it right now, and it's something that you will use on your homework. So basically, what we're going to draw right now, or we're going to create a table of sums, and we will utilize that to look at for each of our problems. Give a little bit of time just so people, if there's too much writing here, to get caught up, because we're going to move on to the next page and create our table index. All right. Summation table index for base 8 octal. Our table is an 8 by 8. 1, 2, 9 by 9. 2, 3, 4, 5, 6. 6. So we need a 9 by 9 for my picture. So I drew 8 lines that go into the middle. And I'm going to do the same thing for 1, 2, 3, 4. 5, 6, 7, 8. And one more. 9. So we're going to talk out here about sums, and we're going to label the numbers of the digits: 0, 1, 2, 3, 4, 5, 6, 7, and the same thing going down: 0, 1, 2, 3, 4, 5, 6, and 7. Now this is very similar to a table that you have built before. Now I in my table I used 0. Oftentimes in other indexes they don't utilize the 0 one, but since it's in regards to one of our digits, I included it. But again, 0 plus anything is just a number, so it's kind of typical in terms of it. So we're just going to add. So what I mean by here is that we're going to add each number, whatever the number is, we'll add it. All right, for example, 5 plus 2 is 7, so a 7 would go down in here. Now, of course, you're thinking, well, man, I have to do a bunch of additions just to figure this out. It's just a pattern. 0 plus anything gives you the number. So 0 plus 0 is? 0. Yeah. Plus 0 plus 1? 1. Yeah. And so if we can see here, there's that pattern right there. This pattern also goes downwards because 0 plus 1, so we would have the same thing here. And what happens in terms of the base part of it is that everything just ends up kind of shifting over. You could think of everything shifting to the left because 1 plus 1 is 2, and then 1 plus 2 is 3, and then of course 4, 5, 6, 7. And it's when we get to that next space where things are going to get a little bit different, okay? I'm going to hold them right here. I'm just going to hold off on those ones right there. 3, 4, 5, 6, 7. 4, 5, 6, 7. 5, 6, 7. 6, 7, 7. These numbers right here, we don't need to worry about too much because addition over on these numbers is the same. There's nothing different in terms of how we do addition. You might have done a table very similar to this when you were first learning how to count and add during, you know, elementary school. So now is when things get different, all right? Because now when we get to a number bigger than 7, we have to add in a new digit. And remember, the first new number in a numbering system is always going to be 1, 0. All right. Whenever you go in past the digit and you have to add a new digit placement, you get 1, 0. So as a result, our next digit after 7 is
7.
No. After 0 comes, or after 7 in octal.
8.
Well, 8, there's no 8 in octal. And I just had given you the answer just a moment ago. There's no 9s, there's no 8 or 9s in octal. I just said once you've passed the maximum amount of digits that you can have, or the number, you must add a digit. So we have to go to a 2-digit number. Close now in terms of the chat, that was close. We have to go to the next digit. And so as you remember, if you can recall, remember 8 is equal to 8. 1 times 8 to the 1 plus 0 times 8 plus 0 times 8 to the 0. So 8 is 1, 0. 9 in octal would be 1 times 8 to the 1 plus 1 times 8 to the 0, which would be 1, 1. So this gives me 1, 0. So we go from 7 to 1, 0 to 10. Or you know, most of you are saying 10. And if you want to call it 10, go ahead. I like to call it 1, 0. Or you know, I guess we can go 10. And so that 10 happens each way. So that's 10, 10, 10, 10, 10, and 10. Because 7 plus 1, 6 plus 2. Now you can memorize that 8 is 10, but then that's going to be a little bit more difficult. So we're going to use this table. After 10 comes what? The math works nicely after this. After 10 comes what?
11.
Yep, so we got 11. So 11, 11, 11, 11, 11. After 11 comes
12.
I think you're seeing the pattern here. Then 13. Then 14. Then 15. And finally 7 plus 7 is 16.
14.
16 for an octal. So remember, these are the base 8. All right, this is base 8. And I guess, you know, I'm going to These are all how you add and you get in octal. Now, any octal plus 1 moves to the next value. And always remember that 7 plus 1 always gives you 1, 0. That's the biggest one. There is no 8 in octal, and that's going to be the toughest one. But it won't actually happen in any of the math that we get to. Well, I guess no, because you might get 9 or you might get 7 and then have to add in 1. So that's the only tough instance right there when you get 7 plus 1 that you might have to memorize. And what I mean by that is, i.e., 2 plus 5 plus 1. This would have given you 7, and so we get to 8. Which there is no 8, so we get to 1, 0. That's the toughest instance. That's the toughest instance because we're only going to be adding 2-digit numbers. So the biggest thing here is that we need to reference the table for any addition sums greater than 7. So the reality here in this table is all we need is this purple part on the right. That's the only thing that you're going to have to reference in tomorrow's work or in today's homework and work. Okay? Now, if none of the numbers when you add them get bigger than 7 for any digit placement, then the addition is just going to be nice and straightforward. It's going to be the exact same thing. So let's do an example. Can someone give me a 2-digit number? That's an octal number. Someone give me a 2-digit octal number.
11.
Okay, 11, and we'll add to that. Give me another 2-digit octal number.
14.
14. So this is the same. This is an octal. So basically each one of these is base 8. Now I'm not going to write this base 8 in here. You're not going to really see this base 8 part right like that. I'll write it on this problem right here. But I'm telling you these numbers are octal. In decimal, you're not going to need to do this, but this is the same thing as 9 plus 15. No. 9 plus 12. So this is the same thing as 9 plus 12 that we're trying to do, which we know is 21. And you're like, well, if I know it's so easy than 21, why don't I just convert to decimal every single time? And then I can just do addition like I normally do, and I have no problem. Well, we want to learn how to utilize different numbering systems. And of course, converting is not what we really want to do. We want to just leave our numbers in octal. But the nice thing about this problem is that when we add these numbers, we're not going to get anything greater than 7 for any placement values. So for example, what's 1 plus 4?
5.
5. 5 is a digit in octal, so we just keep the 5. There's nothing special. No carrying, no anything. And 1 plus 1?
2.
Is 2. And that's my answer. And if you don't agree, this is the same thing as 2 times 8 plus 5, which is 16 plus 5, which gives me 21. So, but we're not. I'm not going to ask you to convert or to show the decimal additions. I just want you to add the numbers in octal and leave your answer in octal. You're not going to have to convert at all. We're just going to leave it in octal. Now, just as we can see here, in this example, none of the placement digits, none of the placement digit sums was greater than 7. Normal addition. Now let's do an example where that is not the case. And once again, these are octal. So can someone give me some bigger type of 2-digit octal? We'll stay with 2 digits right now, but let's go with 2 digits. Let's go with something that's bigger. That's maybe not using the number 1 or zeros, just so that we make sure that happens. Give me a digit.
So no 1 and zeros.
I just said let's not use ones or zeros for this one so that the math does what we want it to do in this example. 24. And we're going to add 24 to 75. All right. So 24 plus 75. Now these are both base 8. This is not 24 plus 75. These are base 8. And so what I realize here is that I got to get 4 plus 5, which gives me 9. And that's where the problem is. I would usually do 9, but 9 does not work. 9 is not an octal. 4 plus 5 is 9, which is greater than 7. So we can't do that. We need to use the table. So all I'm going to do is I'm going to go 4 plus 5. All right. So 4 plus 5 is 1 or 11. All right. 4 plus 5 is 11. Now, some of you can just memorize, what the digit number placements are, but this is the easiest way. 4 plus 5 is 11. So in octal, 4 plus 5 is actually 11. This is from the table. So that means we're going to put the 1 here, and what are we going to do with the other one?
We're gonna put it on the 2.
Yeah, we're going to carry the 1. It's the carry. Now we have 2 plus 7, which is 9. So I go back to my number system. 2 plus 7 gives me 11, but I'm going to do plus 1. So 2 plus 7 is 11, but I have to add 1 more, so what do I get?
12.
12. And that's it. So 2 plus 7 was 11. 11 plus 1, just 12. Because when you add 1, you pretty much are just going to go to the next number up. The only instances is when you get to 7, and then you have to go a little bit bigger. So my answer is 121. All right. Let's go bigger. Let's go 3 digits, which most of your homework problems are actually 3 or 4 digit numbers. All right, so in this example, add the following octals. A. So 2, 7, 4 plus 3, 5, 2. All right. 4 plus 2?
6.
So 6 is good for us. All right, we don't need to do anything for 6. So 6. 7 plus 5.
14. Put the 4 and carry the 1.
So Eliana is looking at 7 plus 5 is 14. He looked at the table. He did not tell me 12. And that's exactly what I don't want you to do. It's not 12. 7 plus 5 is 14 in octal because 7 plus 5 is 14. So the 4 carry the 1. Remember, 7 plus 5 is 14 in octal by the table. And then 1 plus 2 plus 3 is 5 plus 1 is
6.
And that's perfectly fine right there. Does not give me a number greater than 7, so I can use it. So my answer is 646. Let me see. 1, 0. Nope, can't use an 8. 1, 0, 5, 6 plus 7, 5, 1, 7. Let's go with 2 here. All right, here's what I have. So remember, you got to kind of look at that table, and you got to, when you know the answer is more than 7, you have to go to the table, or at least that's the easiest way, and that's the way I'm pushing you towards. So 6 plus 7 is not 13. Okay, it's not 13.
It's 15.
It's 15, exactly. Basically, you're just adding 2 numbers. You're just adding 2 in terms of when we're doing all of these problems. If you notice, that's another pattern, but that's only a pattern specific to octal. I mean, I guess you could think of that, and only when you're using 2 digits. So 6 plus 7 is 15 in octal, because this is an octal number. So I get 5 and carry the 1. Now, 5 plus 2, I always like to do the first 2 and then I add the 1. 5 plus 2 is 7. Uh-oh. This is where we get the tricky one. And I get 7 plus 1, which is not 8. There's no 8 in octal. This is that instance right here where we got, so 5 plus 2 plus 1 would be 8 in decimal. But in octal, that is what?
10.
It's 10. That's that instance right there. That's 10. Because that's 7 plus 1, which is 10, which I told you is the little trickier one. Because 8 is equal to 10 in octal. So I get the 0, and I carry the 1. Okay, 1 plus 5 is
6.
So that's nice. I don't have to do any carrying or converting of the table. And 1 plus 7 is
10.
Is 10. And this is my answer in octal. All right. You don't have to use a subscript 8. I put it there just to remind you that this is octal and this is not, we're breaking math. No, the math that we set the parameters for base 10 in our mathematics system, accounting system. You know, in some cultures or in some worlds, the way we're doing the math by normal means might be breaking the system. So that's what you're doing. That's your homework. I reduced the number of problems to 6 versus the 8. The homework problems are on Google Classroom. Tomorrow, we will be adding in hexadecimal. All right, so tomorrow, addition in hexadecimal, which means we're going to be able to figure out what's A plus B. We'll have that answer for you tomorrow. That's what I have for you, and I will see you tomorrow.